Hi guys, in this video we're going to look at acid-base ionic equations. So first of all, what are ionic equations? They're equations that show us the species, in other words, species means thing, so it could be an ion, a molecule, whatever. The species that directly take part in a reaction. And state symbols are really important in ionic equations because anything that's in the aqueous phase will split up into its ions, and anything that's not won't do this. Now water, we give that a liquid state symbol because aqueous means dissolved in water, and we can't say that water is dissolved in water. It just is water. So here we've got some balanced equations, and anything that's got an aqueous state symbol, let's show that splitting up into its ions. So HCl, that will split up into H plus and Cl minus. Sodium hydroxide, that will break up into a sodium ion and a hydroxide ion. And then we've got the salt, sodium chloride, which will also break up into its ions. Now the next step is to cancel out any ions that we see on the left and the right of this arrow. So we can see we've got a sodium ion that's on the left and on the right. We can cross that out. We've also got a chloride ion that's present on the left and the right, and we can cancel that out as well. Now these ions that we've cancelled out, they're called spectator ions. And a spectator, like at a sports match, is someone or something that just sits and watches. They don't take part directly in that reaction. And then we can write out what we're left with. So the things we haven't cancelled out, that's H plus and OH minus, which react together to give water. Let's have a go at this second one then. It's very similar. It's still acid and base. They're all acid and base, these ones. The only difference here is that we've got a diprotic acid. So in other words, it's got two acidic protons instead of one, like HCl, and that affects how we balance the equation. So same thing again, everything with an aqueous state symbol is going to break up into its ions. Here we'll have 2H plus and a sulfate ion whose formula is SO42 minus. Then here we've got two potassium ions, so take into account the numbers here, and two hydroxide ions, because that big 2 means we've got two lots of everything that comes after it. Then here, two potassium ions again, sulfate ions. Okay, same thing. So we're going to look for the same type of ion that appears on both the left and the right of this arrow and cancel them out. So we've got potassium, we've got sulfate, and what are we left with? That will be the ionic equation. So we've got 2H plus 2OH minus, which gives 2 waters. And of course we can simplify that. If we divide everything by 2, we get H plus OH minus, which gives water. So that's showing us that these are the ions that directly take part in this neutralization reaction. We've got the acidic part of the acid, the protons, and the basic part of the base, or alkali if you like. An alkali is a soluble base, and they react together to make water. And everything else that we've crossed out does not participate directly in the reaction. They're spectator ions. Let's do the last one then. So we've got HCl again, and there's a 2 in front from when we balanced it. So 2H plus and 2Cl minus. Here we've got copper oxide, that's a base, and it's in its solid phase, so that will not break up into its ions. We leave that alone. Then here we've got the salt, that's in the aqueous phase, so copper 2 plus and 2Cl minus. And water, that's liquid, so we leave that. Okay, so what ions have we got that are the same on the left and the right? We've got the chlorides. They were spectator ions in the first one as well. And that's all. So what are we left with? 2H plus the copper oxide, because that's solid, so that stayed intact, which gives copper 2 plus ions in solution and water. Hopefully that was helpful. If it was, please like and subscribe. Thank you.